The owners of Morgan's Department Store want to construct a rectangular parking lot on land bordered on one side by a highway. The store has 280 feet of fencing that is to be used to fence off the other 3 sides. What should be the dimensions of the lot if the enclosed area is to be a maximum? What is the maximum area? Now, let's define our variables and let's let x represent the length of the equal sides of this lot. So we have a lot along a highway. It's going to be rectangular, so we know that 2 of these sides are going to have the same dimension, which I'm calling x. Now, we're given 280 feet of fencing to work with, so the remaining side of this lot is that total of 280 minus these 2 x's. We've defined our variable. Now let's write an equation. We're given information about area. We want to maximize the area, so let's start there. The area of a rectangle is length times width. We've described the dimensions of our rectangle as x and 280 minus 2x. So let's use those for our dimensions. Now, we want to find the value for x that's going to maximize this area. Let's go ahead and multiply x through and write this as 280x minus 2x squared. I'm going to bring that negative 2x squared out into the front so that we can see this as an area function whose graph is a parabola. Notice our leading coefficient is at negative 2, so this parabola, if we graphed it, is a downward opening parabola. And what we're doing here is we're looking for this vertex value. If we want to maximize the area, then we want to find the x value that causes this highest point on the graph. So let's find the values for that vertex by using the vertex formula, where the x value is negative b over 2a. That's a negative 280 over 2 times a, or negative 2. That's a negative 280 over a negative 4, which is a positive 70. This is a dimension in terms of feet. Now, if x is 70 feet, then our other dimension was given by 280 minus 2x. That's 280 minus 2 times 70, 140, or a 140 feet. So our dimensions that are going to maximize the area are that lot should be 140 feet by 70 feet. Now, one last question. What is that maximum area then if we use these dimensions? We can answer that by using our area formula and multiplying our length times our width, multiplying 140 times 70 to get 9,800 square feet. Dimensions, 140 feet by 70 feet. Maximum area, 9,800 square feet.